What is up, everyone? This is going to be the first episode of the Rust for Beginners series, where we are going to create a complete trading engine, a matching engine in Rust. We're going to start very simple and we're going to build it up so you guys will have a complete project in Rust, learning you everything you need to know to become a professional. All right, so let's get started. The first thing we're going to do is cargo new, which will basically give us this nice, beautiful project to work in. And I'm going to write everything right now in the main rs file, and we're going to split things out as we go. All right. So for a trading engine, it's basically a matching engine, which will, if we place an order on an exchange or something, it will try to process that order and match it with other orders in the order book, with the asks and the bids, right? So we're going to make such a project. It's very nice for beginners because we're going to learn a lot of stuff as we go, right? I think it's the best way to learn is to do a project instead of doing these smaller tutorials. And I'm going to keep it short, each episode, so you can have a good focus going on. So we need a couple things, right? So what do we need? We're going to make some structs. The first thing we're going to do is make an order, right? We're going to say that order is going to have a size, which is going to be an F64. We're also going to make an enum, right? An enum, and it's going to be a bid or ask, which basically means if we place an order, we need to specify if it's going to be a bid or an ask, if it's going to be a buy or a sell order, right? So we're going to say bid and then ask. So we could say that the bid or ask is going to be a bid or ask type, right? Cool. So let's implement some constructor for this order. We're going to say implement order. We're going to say event new, which will return us an order, right? Like this. And we're going to say bid or ask is going to be a bid or ask. And then we're going to say that the size is going to be an F64, right? And then we can just, we don't need to return in Rust. We can, but we don't need to, is just say order. We're going to say that the bid or ask is this, and the size is going to be that. So if your namings is the same as if your arguments of your function or your variables is the same as those one in your struct, you can just specify it like that. You could also do size is size, and bid or ask is bid or ask, but it does not need to be like this. This is the way to go. All right, so we can make a new order. That's already a win. The next thing we're going to do is make a limit, right? Because what is a limit? Well, let's make it first and I will explain. A limit is going to have a price. And already we're going to have a problem because you would think, yeah, we could just do an F64 for this, which is a float. But the problem is we're going to put that limit into a hash map, and F64s is not that good for hashing. It can give us inconsistent values, and we don't want that, right? So what is a limit? In order books, we have limits sitting at a certain price level, and each limit is basically holds a bucket of orders, right? It can have different orders from different users with different sizes, okay? And all these orders have, of course, one thing in common, and that's the price, right? So we need to have, instead of doing an F64, we're going to make our own price structure, our own price implementation. So it's going to be safe for hashing and putting it into a hash map. We're also going to have a bunch of orders, which is going to be a vec of order like this. And let's make this price real quick. We're going to say struct price. We're going to divide it up into integrals fractions. We're going to say integral is going to be a U64 like this, the fractional also, and of course we need a scalar like this. We're going to make an implementation. We're going to say implement price, event new. We're going to give it, this can be just a price, a float 64, and we're going to convert it, right? We're going to say we're going to return a price like this. Let's hardcode our scalar in. We could do something 100,000 or something. We're going to say that the integral part of the price is going to be the price as U64, right? So what is as? We're basically gonna cast a float to an int, which basically will give us the integral part of our decimal. And then we're gonna say the fractional is going to be, it's going to be the price modulo times the scalar. We're going to scale it up so we don't have any decimals. I think SU64, SF64 is scalar like this. And can we actually do this? Let me say scalar, integral, and fractional. Integral. We made a mistake. Yes, that should be good. The fractional is going to give us a problem because we need to cast this to a U64. So we're going to wrap this thing and cast it to a U64. That's what we're going to do, and it should all work fine. So let's quickly test this, right? So we could do, say, let price is going to be a new, is going to be a price new, and let's say 50 and a half. And then, of course, I will show you this, right? So if we place this, if you want to debug something in Rust, you could do this, right? A semicolon question mark, and then put our price in. But it's going to complain because it's going to say price does not implement the debug thread. So we're going to say, we could do the macro here. We're going to say derive, and we say debug, right? And it automatically will implement that for us, which is noise. And then it's going to work pretty fine. No compiler errors. So we're going to say cargo run. And we can say we have our price here, which is integral is 50. The fractional is 50,000 and the scalar is 100,000. So if you want to construct this again, the fractional, we can basically divide it by the scalar, and it's all Gucci, right? Okay. So this limit is fine. What do we need is maybe an implementation for our limit. So let's say implement the limit like this. We're going to say, of course, again, event new, which is going to return a limit. And I think it's fine. If you want a new limit, we could say a new limit for a price, and this can be an F64 because we're going to convert this with our logic we already implemented. I think it's good because if you want to make a new limit, we need to specify on what price level this limit is going to hold orders for. So we could say return as a limit. The price is going to be price new. Right, we can call this function. We're going to say it's going to be price. And then we're going to say that the orders is going to be a vec new. Yes, and that should be good. Containing no orders. All right, so let's test this real quick. Let's say, let's delete this. And I will put this a little bit higher so it's easier for you guys to follow. So we're going to say let limit is going to be a limit new, and we're going to say the price is going to be at 56.5 or something, or 3, whatever, and then we can actually print out the limit or not. We will see. Probably not, because we don't have debug for the limit. So we could do the same thing again. This macro, I'm going to say derive debug, right? Debug. Hop. Did I make? I need to place it here. My bad. Hop. And then do a cargo run. Wait, I made a mistake here. What is this compiler error? Order is not, okay. So we cannot do this because we say here derive debug, but that basically requires us that all other types we have also have debug, right? And we already did this for price, but we didn't do this for order. So we can basically copy this here and actually paste it above the order, and that should be, of course, bid or ask, the same thing. It's like a cascading waterfall, right? So now it requires us to have debug for our custom enum. And I think now everything is Gucci. So let's cargo run this once again. All right, so we created our new limit. It's basically the price, the integral, the fractions, and you see already we have some shenanigans going on because it's 3 and it's already, but if we can round it up above, it's all fine. We need to make this implementation a little bit better later on, but for now it will work fine. And we have an empty orders, that's good, right? So what we also need for a limit is actually a new function. We're going to say add order, and that's going to be we need to have I think we need to have a mutable self, right? Because we need self, so we have access to our variables, and we need to call this as declare this as mutable because we are actually going to update the order vec, the order slice of array or list, whatever you want to call this. We're going to say order is going to be an order like this, and it's not going to return anything. So we're going to say self orders push, I guess. We're going to push this order into the list. That's what we're going to do. And we're going to test this real quick. So we're going to make a new limit. Let's make a new order. Let's say buy order. We're going to make a buy order. Like this is going to be order new. We need to give it a price, a size rather. Let's make this 60 round. It's a little bit better, easier to read. We're going to say place me an order, and the size is going to be 5.5. And of course we need to specify if it's going to be a bid or an ask. So we could say that's the bid or ask, and it's going to be a bid, of course, like this. Hop, and then we can say limit add order, and we're going to say add me the buy order, right? Of course we're going to have an issue, right? And I did it on purpose. So basically what the compiler is going to say that you are borrowing this thing as a mutable, but limit here is not a mutable, right? In Rust you need to declare, if you want to declare a variable, you need to tell the compiler, hey, this is my variable, and it's all good. I'm just going to assign it and use it, and I'm not going to update it. But if you're going to update it, if you're going to modify some state, you need to declare this as a mutable, right? And then it's all good. So let's test this real quick. Cargo run. Yes, so you can see we have our limit right here, and which is this, but on this price level, right? And then we have our orders, which is the new order we made. It's a 5.5 as the size, and it's a bit, right? And we could do the same thing. We could actually copy this order and say this is going to be a sell order, and instead of saying bid, we can say ask, and let's sell for 245 or something. And then we can say add me another order, the sell order, and cargo run this again. All right, so now we have 2 orders in our slice, in our limit. All right, cool. The next thing we're gonna do is make the order book, okay? So, and we're gonna split this out real soon. Trust. Let's do it here. We're gonna say type, no, it's not type, it's Golang. It's Golang shenanigans going on in Rust, oh my God. We're gonna say struct order book, like this. We're gonna say event, no, man, I'm confusing. I'm mixing things up. So what does the order book need? We need to have asks, which is going to be a hash map. And can it import this for us? It can. Boom, like this, insane. It's going to be a hash map of price with a limit, right? And it's like this. So we're going to have asks, which is basically a map where we put the price as the key. So we can actually, if somebody want to place a new order, we can fetch it by the price, and it will return us the limit. So we can maybe add a new order to that limit, right? It will all make sense. It will all make so much sense. So a hash map is basically simple. It's like you know it, it's a hash map, right? Nothing more to explain about this. It's collections hash map. And if you use any kind of IDE or VS Code or whatever, or even Vim with some plugins, it will import everything for you. So we need asks, but we also need bits, right? Because we're going to have sell orders and buy orders, and it both are going to be hash maps. So let's make an implementation. It's going to be implement the order book. We're going to say event new. Do we need something? Maybe later on we're going to add stuff to it. We're going to return an order book. We're going to say order book like this, hop, and then we're going to say that the asks is going to be a hash map new. And it will automatically instantiate this because we already told the compiler what it's going to be, and I imported something I don't need. So let's delete this. And then we also need the bits like this. And I think that's good. Right. Okay, so what do we need, right? So we have an order book, and people are going to place orders, right? And I'm thinking, should we do place orders directly on the order book, or should we make some kind of an engine? An engine kind of thing. Maybe we should do that. Actually, let's do something like add order. Right? If an order comes in, maybe we'd say add limit order. That would be nice, right? So what is the difference between a limit and a market order? A limit order will sit in the order books, while a market order will always be filled and will never sit somewhere. It will be go to our exchange, go to our matching engine, and it will be filled by a limit order, right? While a limit order will sit somewhere at a certain price level, at a certain limit. So we could actually say add order because that will make more sense. We're going to say add order is going to be an mutable self because we're going to update one of these maps. So we need to declare ourselves as mutable. And we could say order is going to be an order, right? Something like this. And it's going to return nothing. I guess maybe we'll implement something later on. All right, so we could say if there is an order, we could match, right? And in Rust, you have something what is called pattern matching. So we could say match the order bit or ask like this. And we're going to say a couple cases. We're going to say case bit or ask, case it's a bit, right? We can match it like this, and then we do this, right? And you can write code like here, but you could also open your scope with your parentheses, right? Let's do it back like this, and then I can copy this and say ask like this. All right, and then I'm gonna say if it's a bit, we could say let limit. Let's fetch the limit first. The first thing we're going to do is check if there's a limit already. And if there is already a limit, we can add the order, right? Wait, we need to add order at a certain price, right? So we could say price is going to be an F64 like this, right? Because we're going to say, hey, order book, add my order at that level, at that price level. So what we need to do is check if our order book already contains that price limit. And if so, we can add that to the limit. And if not, we create a new price limit and add the order there. That's the goal. So we're going to say let limit is going to be self. First of all, we need to construct the price, I guess. So we could say let price is going to be price new price like this, and then we could say self. If it's a bit, we're gonna check the bits, right? Self bits get mut. If I'm correct, wait, let me see. It should be the price And what is this? Yeah, I need to do, I will say what's going on here in a moment. Yeah, so the problem is that we, because it's in a map, right? If you check the compiler, and that's what Rust is all about, is understanding what the compiler is yelling at you. Because a lot of people have issues with Rust because sometimes they don't know what's going on. And even for me, sometimes I need to check. Sometimes I forget things. So a couple things are not satisfied for price, and that's equal and hash. And it's needed because it sits in a hash map, so it needs to satisfy these things. Because price is not a standard type, right? So where is our price thing? This is price, so we could do something like derive me equal, derive me partial equal, and also derive me hash. And I think that should be good. Not quite sure. All right, and then of course we need to pass this by a reference. If you don't know something, you can basically check what the compiler is telling you, and it should be all good. And Rust is improved a lot. The compiler is improved a lot. So you're going to have a good time. All right, so we have this limit, right? And the thing is, get mut basically returns us an option, right? But you can unwrap this, but we're going to say we're going to match again. So we're going to say match on the limit, like this, and then we're going to say case sum, right? It's a very common pattern in Rust. Case if there is a limit, if there is some limit, right? We could do this, and we could say, for example, let's make a print line. We could say already got a limit, like this, and then we could also do case none, right? Case none. We could say println need to create a new limit, right? Because if there is no limit, we need to create one. If there is a limit, we can add one, right? So let's try to test this real quick. So we have these limits. We don't need this limit. We have this by order. So what we're going to say is, let's create an order book, and we're going to say a mutable order book is going to be order book new. And then we're going to say order book, add an order, and that's going to be the by order, right? Because we don't have implemented the cell orders yet. Add order by order, and we need to specify a price. Let's say 4 or something. I don't know. Right? And then we're going to print out the order book like this. What is going on here real quick? Yeah, of course. Order book does not implement the debug. We forgot this. So we're going to say derive me debug. Debug like this. Up. Yes, that's working. Let's see what cargo run has to tell us. So we have a new order book, and it tells us here need to create a new limit, right? And that's because there is no limit, right? Because we didn't implement it yet. So what we're gonna do, right? It said here need to create new limit because limit is empty. So let's implement this non statement. Right, I'm gonna repeat. If you have an option, it could be something and it could be nothing. And that's pretty nice in Rust. You can pattern match on that, right? Do we have a limit or don't we? And you can handle these both cases. Basically, if else. And you can pattern match, you can do a lot of more nice tricks with it, and we're gonna cover that soon. So none, we're gonna say, wait, this is gonna be, this is confusing. We could actually do something like this, right? Not quite sure if this is going to work, to be honest. Cargo run, let's see. What is this actually telling us? Remove these parentheses. Why did the compiler did do it for us, right? What's going on? All right, because otherwise we have limit. It doesn't make sense because it will shadow these variables. So what we're going to say here is let limit, and we need a mutable limit actually. It's going to be a new limit, right? Because there is none. We need to make a new one. And we're going to say it's going to be that price. And we're already going to have an error, right? We're going to move price here, right? You see? So we're going to make a new limit, the price we just created here. And it's going to probably say, oh yeah, we can just do... Should we actually... Maybe we should do here actually say price and instead of creating a new price again. Not quite sure. Let's try this real quick. Let's do things on the fly. Yeah, so new price, that's maybe better because we have it already here, right? So that's the limit, and then we're going to say limit add an order, and it's going to be the order it gives us at a certain price level. Wait, now I'm confused. So add order is going to be... Oh yeah, no. Yeah. My bad. So we can just add order. And then we need to add a limit to our order book, right? So we're going to say self bits insert the order. Wait, we need that at the price, right? So we could say at the price level, insert this order. Wait, I'm confused. Limit. Like this. All right. And I think now we have this move issue. So, yes. So, in Rust, this is a common thing. So we make this price here. We already tell us, so it's all good, right? But then we say, hey, limit, make me a new limit with the price, which is this variable, right? So, but now we are going to insert it once again, and that's unsafe, right? So what we need to do is clone this thing. And you could do this, it will do it automatically, but we need to make sure that it's implementing these things. So we're going to say, I think we need to implement clone and copy like this. And it's perfectly fine to copy, right? It's perfectly fine to copy this. It's like basically like just have an F64, but then in a struct, and you just copy that variable. It's basically nothing to copy. There's not that many bytes, so it's all good. So I think this should be it, right? So we do this add order, make this new limit, add the order to the limit, and then we push it to our bits. So let's see what's going on here. Cargo run. Yeah. So we have this order book. Ask is empty. That's correct. We have bits, right? And we have this key. And then we have a limit sitting on it. And this limit has a price. And it has orders. And it's the order we just actually added, right? So if we should do something like, let's make an other cell order. Let's say cell order from Bob, right? That's going to be the same thing. Wait, we're going to make a bit order. My bad. Wait, like copy this, paste it in here. Let's remove the cell order real quick. And let's say it's going to be the buy order from Bob, which is a new order, which is a bit, right? And we're going to say, this price is perfectly fine. We're going to make our order book, and we're going to say, hey, order book, add me a new order at the same price, right? Add me a new order at the same price level, but from a different person with a different size. And this is going to be buy order from Bob. We could actually say for buy order from Alice, right? Let's update this here. from Alice. Hop. Buy order from Alice. Did I form? From rather. Right? So what's going to happen right now is, well, nothing, right? Because we didn't implement this case. Cargo run. So the cool thing is, it tells us, oh, I already got this limit, right? So it's not added here because we didn't implement that. So let's implement this thing real quick. Where are we? And it's already getting some decent size, the file. So we maybe need to think about splitting it out. So we can also cover how to import things from different files and blah, blah, blah. So, sum limit. We triggered this case. So what we're going to do is delete this shenanigans. And we're going to say, there is a limit. So we could do limit, add order, the order we give it. And actually call it a day, I think. Yes, right. So we have our order book. We have a limit sitting at the price level 4, right? This weird price level. And we have 2 orders, right? We have one from Bob and we have the one from Alice, right? So this is already a very good start. Of course, it's going to be very more complex in the future, but for beginning, this is a very good first start. If you like this video, please consider subscribing to my channel. If you have some questions, leave them in the comments, give me a thumbs up, and you can also join the Discord community if you want to discuss more and get some help. Thanks for watching, and I see you in the next episode. Bye-bye.